dining room. So then we move into the kitchen. So this line across the top here is 6. So 1, 2, 3, 4, 5, 6. Right, then the kitchen at the side is exactly the same length as the dining room. And then across there. Okay? Right, next is 10 centimeters down for the sitting room. So we're going to insert 10 centimeters starting here. So 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's right, is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Now, if this bit here is 3 and the whole thing is 14, that means the sitting room has to be 11 centimeters across. So 11 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11. Straight line then from here back up. Nearly there. So this back up. Yeah. And then the bit in the corner is the hall. So it's supposed to be 3 centimeters wide. So is that what it is? 1, 2, 3. Yeah, that looks right. And then the line comes all the way back down from here. Now, so that's what we have. And then if I fill in what that's what each of those are, sorry, you just kind of have to, I suppose, annotate the diagram. Okay, so this one here is the dining room. That's the dining room, and that was what, 8? No, so this is 4 meters, which in our scale was 8 centimeters. And then here we have 6 meters, which in our scale is 12 centimeters. This one here then is the kitchen. It's 3 meters in real life. On our scale, it's 6 centimeters. Down the bottom here, we have the sitting room. So the sitting room was 5 meters here in real life and 10 centimeters here. And then that just left the hall, which was 1.5 meters or 3 centimeters on our scale. Okay, so if I scroll out, there is your scale, draw on graph paper a scaled diagram of this ground floor using the scale 1:50. So I divided everything by 50 and I drew a perfect 2-scale diagram. That's part A. So part B. So part B is to calculate the area of the ground floor. So you're calculating each one of these, and I'm assuming calculate the area of the ground. Oh, on my diagram, sorry, calculate the area on my diagram. So this bit is 8 centimeters by 12 centimeters. I'll do that now. This bit is 6 centimeters by 12 centimeters. We'll do that. Sorry, you guys, I'm just moving. If you just bear with me for 1 second. Okay, so the kitchen was 6 by 12. The sitting, oh no. Okay, we'll do the hall first. The hall is 3 centimeters by 10 centimeters. And then the sitting room is, what did I say the width was? 14 centimeters minus 3. So it was 11 centimeters by 10 centimeters. So 8 by 12 is 96 centimeters squared. 6 by 12 is 72 centimeters squared. 11 by 10 is 110 centimeters squared. 3 by 10 is 30 centimeters squared. And then if we add all them up, so 96 plus 72 plus 110 plus 30, and that gives you 308 centimeters squared for my diagram. So then it was calculate the actual area of the ground floor, first of all in meters squared and then in centimeters squared. Okay, so the actual area in meters, I'll go back here, is 4 by 6 for this one. Try not to mix these up now. 3 by 6 for that one. The sitting room, so what is it across? It's 7 meters minus 1.5. So it's 5.5 meters by 5 meters. Is that right? 7 meters across and the hall is 1.5. So that leaves 5.5 and then it's 5 meters the other way. And if I take 5.5 and divide it by 4, what was it, 50? Yeah, 5.5 divided by 50 gives me 0.11, which is where my 11 centimeters would have come from. And then the last one is 1.5 by 5. Okay. So 4 by 6 is 24. 3 by 6, I'm just going to take this up a bit. 3 by 6 is 18. Yeah. 5.5 by 5 is 27.5. And 1.5 by 5 is 7.5. Yeah? Add them up. So 7.5 plus 27.5 plus 24 plus 18 is 77 meters squared for the whole thing. And then I'll go with yellow for the whole thing in centimeters, because remember you just can't convert straight. Now, there is a way of converting, so if you want to do it that way you can. I'll talk to you about that in a sec, but I'm just going to do the whole calculation again. So 4 meters is 400 centimeters by 600 centimeters. So that is 240,000. So 2, 4, 1, 2, 3, 4. Yeah? This one then is going to be 300 by 600. So it's going to be 1 8 and 4 zeros. This one is going to be 550 by 500. So it's 2, 7, 5, 1, 2, 3. Is that right? 550 by 500. No, that's perfect. And then this one is going to be 150 by 500. So 75000. Okay, and then we add all them up. So 75000 plus 240000 plus 180000, and that comes to 770,123 centimeters squared. Okay, so do you remember I said if you want to convert from meters to centimeters, then you have to convert from meters to centimeters twice. So essentially what you do is you multiply by 100 to convert the first dimension from meters to centimeters, and then you multiply by 100 again to convert the second dimension from meters to centimeters. So that's how we end up with such a big number for centimeters squared. Okay, so we are moving on then to the higher level chapter. So we're in book 2, chapter 19. Like always, a huge amount of this is going to be the same. It's just that the questions are that little bit harder. So you can see here the first bit is your two-dimensional shapes, area and perimeter of a rectangle, area and perimeter of a square, area and perimeter of, or you don't need to do perimeter of a triangle, but area of a triangle, and then area and perimeter or circumference of a circle. Okay, so all of that we've done very, very recently. They talk here about the stuff with pi, where you can either have pi as 3.14, you can have pi as 22/7, you can have pi as the button on your calculator, or you can be asked to leave your answer in terms of pi. So again, we've talked about all that quite recently. Calculating the area of compound shapes, so you just split them up, you do the square and you do the triangle. Okay, so I'm not going to do any examples here because we've done them all so recently. So what I'm going to do is just pick a couple of questions from this section. And the next part is actually some new stuff. So I'm going to pick a couple of questions from this section. It is revision of two-dimensional area and perimeter for a rectangle, square, triangle, and circle. Okay, which we literally only did like at the start of last week. Well, that's when we did circle. So I'm going to pick a couple of questions, like, because these are higher level questions, you'll see that they're that little bit more difficult. Not all of them, but some of them. I'm going to try and pick the more difficult ones. But like, there's nothing different. There's no new formulas. There's nothing that's trying to trick you. It's just that the higher level questions are always that little bit harder. Okay, so let's go with. Okay, so what about, there are two different ones. I don't like that question. Okay, let's do question 9. I do like that question. And we'll do question 10. No, question 9 and question 10 seems fair. Okay, the circle parts are always the hardest, so there's circles in both of those. So I'm going to put these over here. So like I said, no new theory here, just going to attempt some harder questions. So Wednesday, no, the 10th. All right, so those two questions for Friday, and then we'll have our live lesson on Friday, and we'll talk about, like, some of these you've done already. The rectangular solids we've handled, prisms we haven't. Okay, so we'll do prisms. More stuff here about nets, all of that's done. Okay, so there's going to be a lot of that where most of it's done and then some of it's new. We'll get through all of that on Friday, I'd say. And then we've done cylinders, but we haven't done spheres and hemispheres. So in each section of this chapter, we've a little bit that we've done and a little bit that is exclusively higher level. Okay, so it kind of looks like a huge chapter. I was actually scrolling through it earlier going, oh my god, it's huge. But so many of the questions we've done already and we don't need to redo. All right, so those two questions for homework, and I will chat to you on Friday.